Good day, everyone. We are the Group 4, and today we are going to present screws and gears. Ayan. So, next, please. Ayan. So, here are the members of Group 4. First is Melo Mark Christian, Ocanya Paul, Orlanes Neil Ivan, Ranieses Tyrone William, Rico Hermoso John Kirby, Tagbo Adrian, Tan Paul Henry, and Tarsena Christopher. Yan. Next, please. Yan. So here are the objectives for this presentation. Number 1 is to define, explain, and identify the working principle of screws, bolts, and gears. The second is to determine the different types and classification of screws, bolts, and gears. And the third is to establish confidence in applying theoretical knowledge to solve problems dealing with the screws, bolts, and gears. Yeah. So next, please. Yan. So here, so in this presentation, this will be the content that we will be giving to you. So the first part will be about screws and bolts, and in here we will be discuss about bolts and screws, its types of bolts, types of screws, its tolerance, bolt specification number, form of threads for bolts, form of threads for power screws, stresses induced in bolts, and power screws. The second part will be gears, its classification according to the nature of axis, kinds of gears, and under it will be spur gears, helical gears, worm gears, and bevel gears. And um, after that, there will be sample problems. Yan. Next, please. Yan. So let's start with screws and bolts. Next, please. Yan. So screws and bolts. So ano nga ba tong dalawang to? So a bolt is a threaded member designed to pass through the holes in the mating members and to be secured by tightening a knot from the end opposite head of the bolt. So yan, kung makikita nyo is nasa left side yung bolt, yung meron siyang nut. Yan. Yan yung kanyang distinction compare sa screw. Meron siyang nut. Yan. So yung screw naman, it is a threaded fastener designed to be inserted through a hole in one member to join and into a threaded hole in the mating member. And so yung key difference ng bolt and screw is that yung bolt meron siyang nut and yung screw naman is wala siyang nut. Yan. So next, please. And so there are different types of bolts. Machine bolt, eye bolt, stud bolt, stove bolt, U-bolt, and carriage bolt. Ayan, so next please. Ayan, so ito yung images ng different types ng bolt. So yung first one, itong nasa upper left side is siya yung machine bolt. So a machine bolt, also called a machine screw bolt, is a cylindrical fastener used to clamp two pieces of metal together. The bolt consists of threaded shaft with a square or non-hexagon shaped head at one end. A hand or socket wrench that fits the head of machine bolt is used to tighten or loosen the fastener during use. Yan, so kung makikita natin dito, dun sa given example natin, is yung kanyang shape is hexagonal and meron din siyang pinakapakita din doon na meron siyang gamit na bolt. So next naman sa upper middle is yung ating eye bolt. So yung eye bolt can be used as a connection point for rigging, anchoring, pulling, pushing, or hoisting application. Yan. Although eye bolts are commonly used in industrial application, they're also commonly misunderstood or used incorrectly. Ayan. So ito yung image nga ng ating eye bolt. So commonly used daw siya for anchoring, pushing, and rigging. Ayan. And sa out of all the given examples here, yung eye bolts ang pinaka misunderstood at madalas na nagagamit in an improper way. So, yan. Next naman sa upper right is we have stud bolts. So, stud bolts are externally threaded fasteners without a head. Ayan, so kung makikita natin sa out of all the 6 types of bolts, siya lang yung walang head or ulo. Ayan. So, it is used with 2 nuts on either side, substituting a usual bolt and nut assembly. And stud bolts are prominently used in flange connections, and depending upon their design and threading patterns, there are different types of stud bolts. Ayan. Next naman, on the lower left side is we have the, ano nga ba yan? Pabakla, di ko naalala. Ayan, we have stove bolt. Yan, pabalik na ulit. Thank you. And so, it is a bolt with a round or flat slatted head and a square nut. Resembling a machine screw, but usually having a coarser threads and used for joining metal parts. Yan, so ito daw, stove bolt is similar siya dun sa machine screw. Ito yung nasa taas. Pero meron lang siyang coarser thread and usually is ginagamit siya for joining metal parts. Yan. Next naman is itong curved bolt. Yan, so it features thread on each end. Because the bolt is curved, it fits nicely around pipes or tubing. That means U-bolts can secure piping or tubes to support and work as a restraint. So itong curved bolt or U-bolt is usually used as a support in piping systems or tubing due to its shape. And lastly, we have carriage bolts. These types of bolts are usually hexagon, and it is specialized for use in woodworking and woodworking in particular. Yan. Carriage bolts are designed with a domed head which can prevent loosening from one side. An enlarged head shape also prevents the bolt from being pulled through a wooden construction. Yan, so ang key distinction daw ng carriage bolts is it is usually used in wood materials. Yan. So next please. Yan. Dito naman, here we have the different types of screws, and here we have listed 4. And the first one is cap screw. Second is machine screw. Third is the set screw, and the fourth one is the power screw. And so next please. Yan, so ito yung images nung 4 na mention kanina. So the first one is a cap screw. So these are used, cap and machine screws are used to clamp machine parts together. Either one of the parts has a threaded hole or in junction with nut. These screws stretch when tightened, and the tensile load created clamps the part together. Ayan, so kung makikita natin, meron siyang parang cap. Ayan. Next naman is a machine screw. Ito naman, yung nasa upper right is a machine screw. So a machine screw is a type of fastener, like other fasteners, is used to join 2 or more objects. So machine screws are unique, though because machine screws are unique because of their size. So the American Society of Mechanical Engineers, or ASME, defines machine screws as featuring a diameter up to 0.75 inches. So a machine screw daw is ang diameter niya is up to 0.75 inches. Ayan. Next naman is set screw. Set screw, ito nasa upper left side natin. So set screw, socket set screws, or grub screws, they are the type of threaded fastener that is most often used for securing components in place. So this generally means affixing 2 or more loose parts to one together. Ayan. For example, by holding one component tightly against or inside a second surface. Ayan. So, and lastly, at the lower right side is we have naman the power screw. This will be discussed further later on. So a power screw is a mechanical device used to convert rotary motion into linear end to transmit power. Unlike the threaded fastener, which are used to clamp the machine members, power screws are used to transmit power, and its common applications are screw jacks, which is used to lift weights. Ayan. So next time. So ang thread of a screw is a helical shape that runs around the cylinder of the screw. Ayan, so kung makikita natin, siya yung V-shape na siya yung rough part dun sa ating screw. Ayan. So here we have the different parts of a screw thread. So first is we have the pitch. So yung pitch is the distance between the two crest. Yan. So yung crest naman is the top surface of the thread. Siya yung point, yung pinakang pointy part ng ating thread. And yung root naman, siya naman yung bottom surface created by the two flanks. Yung flanks is yung angled na yan. Siya yung angled part. Yung ito naman, yung major diameter is the parang major diameter or the nominal diameter is the largest diameter ng ating screw thread. Yung minor diameter naman, yung minor diameter naman is yung smaller diameter. Siya yung distance between the two roots of the different sides, and the depth naman is the distance between the crest and the root. Ayan. So, ano pa ba hindi ko nababanggit? So, yung helix angle naman is the angle of the helix. Yan. So, yan. Ayan. So, next. Ayan. So, here we have the different types of threads. So, the UNC, which stands for Unified National Course Series, is mostly and usually recommended for general use. And UNF naman, which stands for Unified National Fine Series, are commonly used naman for automobile and aircraft work. UNEF, or Unified National Extra Fine, are used in aeronautical equipments, and 8UN, which stands for Unified 8 Thread, are used in bolts for high pressure pipeline for bolts for high pressure pipe flanges, cylinder head, studs, and etc. So next, please. Ayan. So ito naman yung different tolerances ng ating threads. So class 1A external and class 1B internal are the widest tolerances where quick and easy assembly and even bruise threads are used. Class 2A external and Class 2B internal are tolerances for normal production and the most wide used. And Class 3A external and Class 3B internal are the closest fit with the allowance, which is equals to 0, with 0 allowances. Yeah. So next, please. Ayan. So here we have naman yung bolt specification number. So kanina na-discuss natin yung tolerances at saka yung type of threads. So dito natin siya magagamit in the bolt specification number. So first we have the American and Unified series. So dito makikita natin dun sa example is yung 2-6UNC-1A-RH. So yung 2, it stands for the nominal diameter or the major diameter of the screw or the bolt. Yan, which is measured in inches. Next naman is yung 6 naman is nag-stand siya for number of threads per inch, and yung UNC siya yung ating type of thread. So UNC dyan sa example, meaning siya is yung Unified National Course Series that is recommended for general use. And next naman is yung 1A is yung tolerance naman. So 1 meaning the widest tolerance, 2 normal fit, 3 and the closest fit. And yung A naman stands for, yung A could be A or B, and it could stand, A stands for external and B stands for internal. And yung last part naman is yung RH or LH. So RH meaning right and LH meaning left. So yan, madali naman siyang matandaan. So ito naman para sa metric thread series. So first, yung M stands, so yung ating given nga pala is M-20 by 3-5G. Ayan. So yung M nag-i-stand siya for metric thread series. So yeah, metric thread series. And yung next naman is yung 20 stands for the nominal diameter or the major diameter, which is measured in millimeters. So kung yung American and Unified series is measured in inches, yung atin namang metric thread series is measured in millimeters. So next naman is yung pitch, which is measured in millimeter per thread. Siya yung 3. Siya yung 3 dun sa given. And yung tolerance naman natin, and yung 5G naman is yung ating tolerance. So yung 5 meaning is yung tolerance, and yung G or H could stand for external and internal. Ayan, so next tayo. Ayan, so next naman is yung form of threads for bolts. Ayan, so meron tayong 3 different types dito. The first one is the V-threads, Seller's screw thread, and the Whitworth thread. Yan. So, first discuss natin yung V-threads. So, yung V-threads, yan. Metric ISO threaded screws are V-shaped at the outer edge and are self-locking, so they do not need a screw lock. The flank angle of V-thread is 60 degrees, and it's commonly used for all places where fine adjustment with leads as fine as 0.0125 inch or approximately 0.3175 millimeters are critical, such as microscope stages. And so ang key distinction ng V-threads is yun nga, V-shape siya, and it uses a 60-degree V-shape angle. Yan. So next naman is yung Seller's screw thread. So it is a thread formed in a system of standard sizes proposed by Sellers in 1884. And it is later accepted as a standard in the USA, having a 60-degree flank angle with a flat top and foot. Ayan, so ito namang Seller's screw thread is similar lang siya sa V-threads, pero flat yung kanyang top part at saka yung kanyang root part. Ayan, so 60 degrees din yung angle niya. And yung root naman is equals to the pitch divided by 8. Ayan. So, also proposed din pala siya by Sellers in 1884. Ayan. Whitworth thread naman is a thread form and system of standardized Whitworth thread is a thread form and system of standard sizes proposed by Whitworth in 1841 and adopted as the standard in the UK, having a flank angle of 55 degrees and a rounded top and foot. Ayan, so similar din siya sa V-threads, pero yung angle niya na ginagamit is 55 degrees, and instead na V-shape yung kanyang threads, is ang ginagamit naman dito is rounded yung kanyang crest, and rounded naman yung kanyang root. Ayan. So, next. And so that's all pala for me. Thank you.
So for the important terms, first is the major diameter. It is also the outside or nominal diameter. It is the largest diameter of an external or internal screw thread. The screw is specified by this diameter. Next is the minor diameter. The core or root diameter. It is the smallest diameter of external or internal screw thread. Next is pitch diameter. The pitch diameter of an imaginary cylinder. It is the mean diameter of major and minor diameters. For the pitch, it is the distance from a point on the thread to the next, measured in an axial direction between corresponding points, and lead distance between 2 points on the same helix, the distance which a screw thread advances axially in one rotation of the nut. So next slide, please. Crest is the top surface of the thread, and the root, bottom surface created by two flanks. The depth of the thread is the perpendicular distance between the crest and root. Flank surface joining in the crest and root. And for last is angle of the thread, angle included by the flanks of the thread. The terms will be discussed later, and it is clearly to understand in formulas and computations. So next slide, please. So stresses, induces, and volts. So here are the formulas for the stresses. Next slide, please. First is the shear stress, torsional in the root of the threaded portion, where shearing stress is equal to 16 multiplied by torque over pi diameter inside diameter cube. Next slide, please. Next is the tensile stress at the root or stress area, where tensile stress is equals to applied load over root area is equals to applied load over stress area. For number 3, third is compression stress at the threads. Compression stress is equals to applied load over pi over 4 multiplied by outside diameter squared minus inside diameter squared times number of threads. Also root area and stress area are also needed because of the tensile stress. Next, please. Number 4, shear stress, the simple on the threads at the root. Our shear stress is equals to applied load over pi inside diameter thickness multiplied by thickness times number of threads. The small t is the thickness. So next, please. For number 5, for practical design, from valence, the permissible working stress is equals to bolt constant. Also, bolt constant is equals to 1,000 for bronze and 5,000 for carbon steel. Also, 1,500 for alloy steel. So again, permissible working stress is equals to bolt constant multiplied by stress area raised to 0.418. So for letter B, from FAIRS, the design tensile stress is equals to yield strength over 6 multiplied by area multiplied by stress area raised to 0.50. For the applied load from valence or valence, applied load. Applied load equals to bolt constant raised to 1.418. I'm sorry, bolt constant multiplied by stress area raised to 1.418. Next slide, please. So from letter B, from Fairs, the tensile load of Fairs is equals to yield strength over 6 times stress area raised to 1.50. And for the working strength of the bolt, working strength is equals to allowable working stress multiplied by 0.55 bolt diameter squared minus 0.25 bolt diameter. As for the bolt spacing is equals to pi bolt circle diameter over total number of bolts. And for the bolt circle diameter is equals to inside diameter plus 2 bolt circle diameter. Again, bolt circle diameter is equals to inside diameter plus bolt diameter. Number 10, for the depth top, A for the brittle materials, where H is equals to 1.5. Again, H is the depth of top. For letter B, for valence, the depth of top is equals to 1.25 multiplied by D. And for the steel wrought iron from Fairs, the depth of top is equals to nominal diameter. Again, D is equals to nominal diameter and H is for the depth of top. For the initial torque from valence, first I will set the meaning of the equation. For Fa is of the applied load, Fi is the initial tension, T for torque, capital T for torque, D nominal diameter, H is equals to depth of top, 0.15 is the constant for lubricated, and 0.20 is equals to constant for as received. So from valence, T is equals to 0.20 applied load multiplied by nominal diameter. And from Fairs is equals to torque is equals to 0.20 initial tension multiplied by nominal diameter, or torque is equals to 0.15 initial diameter multiplied by nominal diameter. So next slide, please. And for the initial tension, the Fi is equals to initial tension and D is equals to nominal diameter, which means initial diameter is equals to 16,000 multiplied by nominal diameter. A note, conservative design uses root diameter in the calculation the area handling the load. The latest design uses the stress area as the area handling load. Number 13, last is the bolt elongation. This will be the last equation for the stresses. So bolt elongation is equals to lead multiplied by number of turns.
Next is power screw.
So, ano nga ba yung power screw? Nabanggit na yung power screw kanina na ang power screw is a mechanical device used to convert rotary motion into linear motion and to transmit power. Unlike the threaded fastener which are used to clamp the machine members, power screw are used to transmit power. So, yung power screw ay hindi siya katulad ng ibang threaded fastener na ginagamit for clamps at yung power screw ay ginagamit to transmit power. At makikita natin sa figure kung ano ang itsura ng isang power screw. Nandito yung kanyang pitch, which pitch is simply a measurement of the distance between the threads. And the lead angle is the helix angle of the thread based on the lead distance. A single start thread has a lead distance to its pitch and in turn has a relatively small lead angle. So ano rin ba yung lead na sinasabi? Lead is a measurement of how far a screw will travel after a complete revolution. So power screw are generally based on ACME, square, and buttress threads. So mamaya malalaman natin kung ano yung tatlong yan. And ball screws are type of power screw. And pag conventional power screws, ang efficiency niya ay nagre-range between 30 to 70%. At pag ball screws naman is ang efficiency niya is 90% above. So forms of threads for power screws. Seller's square thread. Square thread is a common screw thread form used in high-load applications such as lead screws and jack screws. It gets its name from the square cross-section of the thread. So, sinasabi dito na kaya tinawag siyang square thread is based on kung anong itsura ng kanyang thread, which is square. At yung crest niya is makukuha sa pitch divided by 2 at yung kanyang height ng thread is madedetermine sa 7/16 multiplied by the pitch. And next is ACME thread. ACME thread is a American screw thread having a section that is mean between the V threads and the square threads. So makikita natin dito na ang ACME thread has a 29-degree angle at yung kanyang root is madedetermine sa pamamagitan ng 0.370 multiplied by the pitch minus 0.0062. And yung height ng kanyang thread ay 0.5 multiplied by the pitch plus 0.01. Next is buttress thread. Buttress threads are designed for handle extremely high axial thrust in one direction. So makikita natin dito na ang buttress threads ay may angle na 45 degrees sa kanyang right at 7-degree angle sa kanyang left. At yung kanyang crest ay madedetermine sa formula na pitch divided by 8 at yung height is 3/4 multiplied by the pitch. Reasons for using power screw. To obtain a high mechanical advantage to move large loads with minimum effort like screw jack. To generate large forces like compactor press. And to obtain precise axial movements like machine tool lead screw. So overall, we use power screw to transmit power. So formula for power screw number 1 is torque required to overcome collar friction. T sub F equals coefficient of friction on collar multiplied by the load quantity multiplied by the quantity mean diameter divided by 2, or we can use the formula of coefficient of friction on collar multiplied by the load multiplied by quantity of outside radius plus inside radius divided by 2. And number 2 formula is torque applied to turn the screw. First is raising the load. T sub F equals load multiplied by the mean diameter divided by 2 multiplied by the quantity of B tan multiplied by lead angle plus coefficient of friction divided by B minus F multiplied by tan multiplied by lead angle. And next is lowering the load. T sub F equals to load multiplied by mean diameter divided by 2 multiplied by quantity of B tan multiplied by lead angle minus coefficient of friction divided by the B plus F multiplied by tan multiplied by the lead angle. So, paano natin makukuha yung value ng B? So, yung value ng B is madedetermine depende sa form of threads ng screw. So, ito yun. Next. Pag ang power screw natin ay ang thread niya is square, ang value ng B niya is 1 at yung cosine niya is 0 degree. And for the ACME, the value of B is 0.968 at yung kanyang cosine is 14.5 degree. Next is trapezoidal metric. Ang value ng B niya is 0.966 at ang cosine niya is 15 degree. And for American Standard Course, ang value ng B niya is 0.866 at ang cosine niya is 30 degree. And for the third formula is total torque required to operate the screw. So, total torque equals frictional torque on the threads plus frictional torque on the collar. And for the fourth formula is power input of the screw. Power input equals 2 pi multiplied by total torque multiplied by rotative speed. Next is power output of the screw. Power output or P sub O equals load multiplied by velocity. Next is efficiency. Efficiency equals output power divided by input power, or we can use the formula to get the efficiency by load multiplied by velocity divided by 2 pi multiplied by total torque multiplied by the rotative speed. And for the linear velocity, our formula is velocity equals rotative speed multiplied by the lead. Next is lead angles. Lead angles multiply tan raised to -1 quantity lead divided by pi multiplied by the mean diameter. And for formula for the lead is L is equal to P if ang thread natin ay isa lang. And for double thread, our formula is lead equals to 2 multiplied by pitch. And pag tatlo ang ating thread, ang ating formula is L equals to 3 multiplied by the pitch. And for the last formula is outside diameter or D sub O equals inside diameter plus lead divided by 2. Next is gears.
Next, gears are mechanisms that mesh together via teeth and are used to transmit rotary motion from the shaft to another. Gears are defined by two important terms, radius and number of teeth. They are typically mounted or connected to the other parts via a shaft or base. Classification of gears according to the nature of axis. Parallel axis. External spur gears. External gears have teeth that are cut on the outside surface of the cylinder. Internal spur gear are gear teeth generated in the internal diameter of a cylinder. Twisted spur gear is also known as helical gear. Their teeth are not parallel to the axis. Herringbone gear is a type of double helical gear. It is a special type of gear that is a side-to-side combination of two helical gears of opposite hands. Rack and pinion. Rack and pinion is type of linear actuator that comprises a circular gear engaging a linear gear which operate to translate rotational motion into linear motion. Pin gearing. Pin gear is a large wheel with cylindrical pin teeth is called pinwheel. Kadalasan nakikita ito sa mga transmission ng sasakyan. Intersecting axis. Gears where the axes of the tooth shafts intersect and the tooth bearing faces of the gears themselves are conically shaped. Crown bevel gears is a gear has teeth that project at right angles to the face of the wheel. Spiral bevel gear. A spiral bevel gear is a bevel gear with helical teeth. Non-intersecting or non-parallel axis. Hyperboloidal. Essentially, regular spur gears with their top and bottom twisted in the opposite direction. Hypoid. A bevel wheel with teeth engaging with a spiral pinion mounted at right angles to the wheel's axis, used to connect non-intersecting shaft in vehicle transmission and other mechanisms. Screw gears, sometimes called crossed helical gears, are helical gears used in motion transmission between an intersecting shaft. Next po. We have four kinds of gears: the spur gears, helical gears, worm gears, and bevel gears. Important terms: pitch circle, imaginary circle by pure rolling action, same motion as the actual gear. Pitch circle diameter. Diameter of the circle gear size is by the pitch circle diameter. Pitch point. Point of tangency of the pitch circle. Pitch surfaces. Surface of the rolling disc. Addendum. Radial distance between the pitch circle and the addendum circle. The addendum is a radial distance from the pitch circle to the root circle, bottom of tooth space. Addendum circle or outside circle that bounds the outer ends of the teeth. Addendum circle, root circle that bounds the bottom of the teeth. Next po. Full depth, total depth. Radial distance between the addendum and the dedendum, the sum of the addendum and dedendum. Working depth. Radial distance from the addendum circle to the clearance circle. It is equal to the sum of both and addendums of the gears. Clearance. Radial distance between the working depth circle and the root circle dedendum minus the mating addendum. Tooth thickness. Width along the pitch circle. Tooth space. Width between adjacent teeth. Backlash. Difference between the tooth space and the tooth thickness. Base of the tooth. Surface between the pitch cylinder and the addendum cylinder. Flank is surface between the pitch and root cylinders. Topland. Surface of the top of the tooth. Bottomland. Surface of the bottom of the tooth space. Face width. Length of teeth in an axial direction. Profile. Curve formed by the face and flank. Fillet radius connects the root circle to the profile of tooth. Pinion. The smaller of two meshing gears. Gear, the larger of two meshing gears. Path of contact. Path traced by the point of contact from the beginning to the end of engagement. Length of the path of contact. Length of the common normal cut off by the addendum circles of the gear and pinion. Arc of contact. Path trace from the beginning to the end and engagement of a given pair of teeth. Arc of approach. Portion of the path of contact from the beginning of the engagement to the pitch point. Arc of recess. Portion of the path of contact from the pitch point to the end of the engagement of a pair of teeth. Angle of action. Angle from teeth come into contact until they go out of contact. Arc of action. Subtends the angle of action. Angle of approach. Angle from teeth come in the contact until contact at the pitch point. and angle of presses. Angle from a teeth are in contact at pitch point until they pass out of a mesh. Velocity ratio. Angular velocity of the driver divided by the driven gear. Gear ratio, number of teeth in gear over pinion. Contact ratio, ratio of the length of arc of contact to the two circular pitch. Base circle, circle where the involute is generated. Degree of involute, define the base circle for a particular pitch circle. And pressure angle, angle between the common normal to two gear of the point of contact and the common tangent at the pitch point.
Spargers. Spargers are gears having teeth that are straight and arranged parallel to the axis of the shaft that carries the gear. The curved shape of the faces of the Sparger's teeth has a special geometry called involute curve. Next. Sparger's nomenclature. Adenum. Adenum, the height by which a tooth projects beyond the pitch of the circle. Dedenum, the depth of a tooth space below the pitch circle, generally greater than the addendum of the mating gear to the provide clearance. Clearance or working depth circle. Ito po kasi yung mga spacing po. Para po mag-connect po yung mga spargers po. And ito po yung karaniwan pong ginagamit po sa sa mga cambio po yung po nasa loob yung pong halimbawa po. Primera, segunda, tercera, kwarta, quinta, reverse. Doon po siya karaniwang ginagamit po yung spargers. Next. Formulas, spargers. Circular pitch. Circular pitch equals pi pinion diameter all over number of teeth in pinion equals pi gear diameter all over number of teeth in gear equals pi module. Next. Diametrial pitch. Diametrial pitch equals number of teeth in pinion all over pinion diameter equals number of teeth in gear all over gear in diameter equals pi all over circular pitch equals 1 all over module. Next. Clearance. Clearance equals D minus A. C equals Full depth minus working depth. Next. Addendum. Addendum equals 1 all over diametrical pitch. Next. Dedendum for 14 1/2 degree and 22 1/2 degree. D is equals to 1.157 all over diametrical pitch for 20 degrees and 25 degrees. D is equals to 1.5 all over diametrical pitch. Next. Outside diameter for pinion. Outside diameter of pinion equals pinion diameter plus 2A equals number of teeth in pinion plus 2 all over diametrical pitch. For gear, outside diameter of gear equals number of teeth in pinion plus 2 all over diametral pitch equals gear diameter plus 2A. Root diameter for pinion. Root diameter of pinion equals pinion diameter 2A. For gear, excuse me, root diameter of gear equals gear diameter plus 2 plus D. Next. Hole depth. Hole depth equals addendum plus dedendum. Hole depth equals working depth plus clearance. Working depth. Working depth equals 2A. Working depth equals hole depth minus clearance. Tooth thickness for backlash is 0. Tooth thickness equals circular pitch all over 2. For backlash is not 0. T is equals circular pitch minus backlash all over 2. Tooth space. Tooth space. Tooth space equals tooth thickness plus backlash. Base circle diameter for pinion. Base diameter of pinion equals pinion diameter cosine theta. Center distance between gears. Center distance between gears equals gear diameter plus pinion diameter all over 2 for external contact. For internal contact is central distance between gears equals gear diameter minus pinion diameter all over 2. Next. Backlash. Backlash equals tooth space minus tooth thickness. Backlash is equals to 0.03 pitch, diameter pitch to 0.04 all over diameter pitch. Face width 2.5 circular pitch less than face width less than 4 circular pitch 8 all over diameter pitch less than face width all over 12.5 all over diameter pitch. Design calculation for spar gears. Next. Beam fatigue strength of the teeth. Beam fatigue strength equals endurance all over K1 diametral pitch. For dynamic load, FD is equals to FT plus 0.05 Vm equals at times multiply BC plus FT all over 0.05 Vm plus BC plus FT. Application commercial cut VM less than equal 200 FPM and the formula is FD is equals 600 plus VM all over 600 times feet. Carefully cut 1000 less than VM less than 400 FPM and the formula is FD is equals 12 plus VM all over 12 times FT. For precision cut, VM greater than 4000 FPM 78 plus VM all over 78 times FT. Commercial hub or shade teeth. The formula is FD equals 50 plus VM all over 50 times FT. Next. Wear load. Wear load equals opinion diameter ratio factor times wear factor. Checking for failure based on fatigue. Service factor equals beam fatigue strength all over dynamic load. Note, NSF or service factor 1 is equals to 1.0 to 1.25 for uniform load without shock. NSF 1.5 to 1.50 for medium shock. For moderate heavy shock 1.5 to 1.75 for heavy shock 1.75 to 2.0. Next. Checking for failure bases on wear. FW greater than equal FD. Next.
Helical gears. Helical gears are gears arranged so they lie at an angle with respect to the axis of the shaft. So itong helical gears ay para din siyang spur gear. Pero yung spur gear ay nakaparallel yung contact to other gear, at ito namang helical gear ay naka-incline yung mga gears or tip, yung tip niya. So yung makikita natin dito sa picture, yung kanyang mga gears ay naka-incline. Yung inclination na yun ay tinatawag na helix angle, na yung inclination niya ay nagre-range sa 15 degrees to 25 degrees. Next po. Helical gears nomenclature. So itong A, ito yung herringbone gears. So itong herringbone gear or double helical gear, they are constructed by joining two identical helical gears with na pares yung number nung tip and pares din yung pitch circle diameter, but with teeth having opposite hand of helix. So parang pinagdikit lang daw siya na helical gear pero magkabaliktad. So tinawag siya na herringbone gears dahil sa shape niya. Ginagamit tong herringbone gears for torque gearboxes kasi itong mga ganito ay has high transmitting capabilities. So ito namang cross helical gears ay mounted on non-parallel shaft. So it means that the shaft are intersecting and the axes of two shafts are neither parallel or intersecting like the worm gears na i-explain mamaya. So they are on different planes and not intersecting. Yung mga ganito daw po ay suitable lang siya sa mga low speed duty application like moving machine o kaya sa mga oil pump of internal combustion engines. Mas flex dahil siya yung non-parallel. Mas flexible yung design niya. Pero naepektuhan yung kanyang transmitting capabilities, kaya yung ganito ay has lower force capabilities. Next po. Important terms, helix angle between a tangent to the pitch helix and the intersecting axial element of the pitch cylinder. The base helix naman, angle between a tangent to the base helix and an element of the base cylinder. Phase contact ratio. It is the advance of the tooth in the line of phase width divided by the circular pitch. Herringbone, ito na yung kanina, are double helical gears consisting of right hand and left hand helices to absorb axial thrust within the gear and are used to connect parallel shaft. Crossed helical gears, ito rin yung kaninang in-explain ko, helical gears mounted on non-parallel shaft. Next po. Formulas sa helical gears. Next po. Sa tangential force, tangential force is equal to radial force over tangent multiplied pressure angle. Next. Sa radial force is equal to normal force multiplied sine pressure angle. Sa axial force naman ay axial force is equals to tangential force multiplied tangent multiplied helix angle. Sa normal pressure angle is equal to inverse tan multiplied tan helix angle multiplied tan pressure angle multiplied cross helix angle. Next po. Axial pitch. Axial pitch is equal to normal circular pitch over tangent multiplied helix angle is equals to pi over diametral pitch multiplied tangent multiplied helix angle. Next po. Normal diametral pitch. Normal diametral pitch is equals to diametral pitch over cosine multiplied helix angle. Next. Normal circular pitch. Normal circular pitch is equals to circular pitch multiplied cosine multiplied helix angle at cosine helix angle ay okay po. Next. Sa lead is equals to axial pitch for single helix. For double helix naman ay L is equals to 2 axial pitch. Sa pag triple helix ay lead is equals to 3 axial pitch. For multiple helix naman ay lead is equals to multiple helix. Multiple axial helix na. Design calculations for helical gears. Next. Beam fatigue strength of the teeth. Beam fatigue strength is equals to endurance stress multiplied face width multiplied Lewis form factor over stress reduction multiplied the normal diametral pitch. Next po. The dynamic load for helical gears is FD is equals to tangential force plus 0.05 pitch line multiplied tangential force plus B multiplied C multiplied cosine squared times cosine squared so yun cosine over wait lang over 0.05 pitch line velocity plus square root of tangential force plus BC multiplied cosine squared yung dulo helix angle. Next po. Wear load wear load is equal to the face width times the ratio factor times times Q plus multiplied the wear factor over cosine squared multiplied the helix angle. Last, the formative number of teeth. Formative number of teeth is equal to the number pitch over cosine cube multiply the helix angle.
Worm gears. Rinig po ba? Dinig po. Hello?
Yes, Rene.
Worm gears are widely used in power transmission applications, in which a compact high reduction and a relative low speed drive is required. Ang worm gears are used to transmit power between non-intersecting shafts, nearly always at right angles to each other. Tas yung advantages of the worm gears include the noise and vibration reduction as well as the compactness. The worm gear system is the most compact type of gearing system, and this makes it capable of place in very small spaces and still providing high ratio speed reduction. Next. Worm gears nomenclature. A worm gear is staggered shaft gear that creates motion uh, between shafts using threads that are cut into a cylindrical bar to provide a speed reduction. Yung combination of a worm wheel and worm are the components of a worm gear. The speed reduction is determined by the number of worm threads and the number of teeth on the worm wheel. And one of the major benefits of worm gears is their ability to offer gear reduction and torque multiplication in a small footprint. In worm gears assemblies, the axial pitch of the worm must be equal to the circular pitch of the larger gear na in the first determination during assembly. Yung circular pitch is the distance between the teeth points on the pitch diameter with axial pitch being the axial distance between the points of the teeth on the worm. Yung threads of the worm may be left-handed or the right-handed. Tapos yung lead refers to the distance a point on a thread travels in revolution of the worm. The lead angle is the angle that is tangent to the thread helix on the pitch of the cylindrical and the plane to the axis of the worm. There are different types of worm gears. The non-throat, first is the non-throat. The non-throat worm gears do not have a throat or groove machined around the worm or worm wheel and are helical gears with a straight worm. Yung tooth contact is at a single point on the moving drive and both gears are non-throated. Having a single rotating point means the gear mas mataas yung wear nito and tear. Tapos yung non-throated worm gears are designed to handle small loads and are easy to make. The other one is the single-throated. Yung single-throated worm gear has incurvate helical teeth designed around sa worm niya for a contact line. Yung type na worm gear na to can withstand higher power without additional wear. In this type of worm gear, only one set of threads on the worm make contact with the worm wheel. Due to the fact that there is a single contact which produces significant friction, yung worm has to be much harder and stronger than the wheel. Next is the double throat. Yung difference ito between the single throat worm gears and the double throat types is their shape, yung shape nila. Tapos yung double throat worm gears naman are concave on the gear and worm screw. Yung teeth naman nito sa gear and the shape of the worm threads are designed to increase the contact between the wheel and worm. And the double throat worm gears are able to handle high loads, and the design of the double throat provides the tightest connection between the worm and the gear. And ginagamit din yung worm gear sa isang example nito ay for yung turning a guitar, yung pag-tune nito. Yan, ginagamit yun doon. Saka sa steering system ng mga sasakyan. And also, yun na. Next. The important terms is the axial pitch, distance. Yung distance is measured actually parallel siya to the axis of worm from a point on one thread to adjacent thread. Tapos yung lead, katulad ng sabi ko kanina, linear distance that a pin on a thread moves in one revolution of the worm. Yung lead angle, the angle between the tangent to the thread helix and the plane normal to the axis of the worm. The tooth pressure angle is measured in a plane containing the axis of the worm and is equal to 1/2 the thread profile angle. The normal pitch is the distance along the normal to the threads between sa 2 points on adjacent threads. And the helix angle angle between the tangent to the thread helix and the axis of the worm, and the velocity ration of the speed of worm to worm gear. Next po. The formulas of worm gears. Next. In the circular pitch or P sub C is equal to the pi gear diameter all over the number of teeth in gear. Next. In diametral pitch is equal to the number of teeth in gear all over the gear diameter. And in the lead, the lead is equal to the number of threads multiplied by the axial pitch. And the lead angle, that is equal to the tan raised to -1, and lead is over tan raised to -1 multiplied by the lead over the pi worm diameter. Next. Pitch line velocity. For worm, the pitch line velocity of the worm is equal to the pi multiplied by the worm diameter multiplied by the rotative speed of the worm. And for the gear, the pitch line velocity of the gear is equal to the pi gear diameter pi multiplied by the gear diameter and multiplied by the rotative speed of the gear. Next. The torque transmitted by worm. The torque transmitted is equal to the tangential force on the worm multiplied by the worm diameter over 2. Next po. In the separating force is equal to the tangential force of the gear sine normal multiply to sine and times normal pressure angle all over cosine normal pressure angle multiplied by cosine lead angle minus the coefficient of friction multiplied by sine lead angle. Next po. And in the tangential force on the worm, the tangential force on the worm is equal to the tangential force on the gear multiplied by the cosine normal pressure angle multiply by sine lead angle plus the coefficient of friction cosine lead angle all over the cosine normal pressure angle multiplied by cosine lead angle minus the coefficient of friction sine lead angle. Next. The efficiency of the worm gear. Efficiency is equal to tangent multiplied by the cosine normal pressure angle minus the coefficient of friction tangent lead angle. All over the cosine normal pressure angle multiplied by the tangent lead angle plus coefficient of friction. Next. The phase width. The phase width is equal to 1/2 multiplied by the outside diameter of the worm. Next po. The outside diameter of worm, where the worm diameter is equal to the outside diameter of the worm plus the addendum. Next. The worm diameter is equal to the center distance raised by 0.875 over 2.2. design calculations in worm gears. Next po. The beam fatigue strength of the teeth, where the beam fatigue strength is equal to the endurance stress multiplied by Lewis form factor multiplied by phase width all over the normal diameter pitch. Is equal siya sa endurance stress multiplied by the Lewis form factor times phase width multiplied by the normal circular diametral pitch all over the pie. Next po. And in the dynamic load for worm gear teeth, the dynamic load for worm gear teeth, dynamic load is equal to 1 2 plus pitch line velocity all over 1 2 multiply by the transmitted load. In wear load is equal to the gear diameter multiplied by the phase width and the wear factor. In thermal capacity, the heat dissipated is equal to 1 minus efficiency multiplied by input power. Next po. And in normal pressure, the normal pressure is equal to tangent raised to -1 multiplied by the tangent pi or p cosine psi. And yun po.
Hello, kinig po ba ako?
Boss.
Bevel gears. So, bevel gears are gears used to connect intersecting shafts, usually but not necessarily at 90 degrees. So, ibig sabihin daw po ay hindi lang daw po siya pwede sa 90 degrees, pwede rin daw po siya sa mga 45, 60, or 120 degrees. So, yung bevel gear, ang bevel gear po natin ay ito pong yung malaki. Sabay itong nakapatong naman sa kanya, ito yung tinatawag nating bevel pinion gear. So, next slide po. So, ito po yung yung terms or parts sa ating bevel gear or bevel gear nomenclature. So, simula po tayo sa apex of pitch cone. So, simula po sa pitch ng ating bevel gear. So, kung makikita natin yung red line, nag-shape siya ng isang cone. So, doon nagmula yung apex of pitch cone natin. So, naka-center line din siya. So, yung atin namang pitch cone, ito yung middle part ng ating teeth. So, yung teeth nga pala natin, meron siyang lower and middle and higher part. So, yung root cone natin, yung lower part, sabay pitch yung middle, sabay face yung upper, yung kadalasan natin makikita. Yan yung parang flat surface, pinakatuktok. Sabay yung atin namang face width, ito yung length ng ating teeth or ngipin. Sabay sa atin namang pitch angle, so simula sa ating pitch cone hanggang sa ating apex of pitch cone, ito yung tinatawag nating pitch angle. Sabay ganon din sa ating root angle, simula sa root cone natin hanggang sa apex of pitch cone natin, ito yung ating root angle. Sa atin namang face angle, face hanggang apex of pitch cone naman natin, ito yung tinatawag nating face angle. So, Yung cone distance naman po natin, ito yung apex of pitch cone natin hanggang sa outside diameter ng ating bevel gear. So, sa addendum naman natin at addendum yung upper part ng ngipin natin. Ito yung simula pitch hanggang sa face natin. Sabay yung dedendum naman, ito yung lower part ng ating ngipin. So, simula sa pitch natin hanggang sa root. Meron din tayong radius pitch. Ito yung parang inner circle sa ngipin natin. Ito yung tinatawag nating radius pitch. Sabay inside radius pitch kalahati lang po pala. Simula po pala sa apex of cone pitch hanggang sa outside pitch natin. Yung inside pitch po pala yung inner circle sa ngipin natin. Sabay sa outside pitch diameter naman natin. Ito naman yung sa pitch, yung huli ng pitch natin, pitch. Tinatawag natin outside pitch diameter. Sabay outside diameter naman, ito yung parang pinaka outer layer ng ating bevel gear. Ano pa? Back cone radius. So, ito naman yung sa likod ng ating bevel gear ay sa ilalim. So, kalahati lang nun since radius. Next slide po. Types of bevel gear. So, meron tayong 5. Straight bevel gears, spiral bevel gears, zero bevel gears, hypoid gears, at spheroid gears. Next slide po. So, sa straight bevel gears natin, it is usually used for pitch line velocities up to 1,000 feet per minute or 5 meters per second when the noise level is not an important consideration. They are available in many stock sizes and are less expensive to produce than other bevel gears, especially in small quantities. So, kadalasan daw makikita to sa mga low speed drives ng ating vehicle. Ito ay makikita rin sa mga automobile differential gear system and other industrial applications. So, next slide po. Spiral bevel gears is the one with spiral angle. These gears are recommended for higher speeds and where the noise level is an important consideration. Spiral bevel gears are the bevel counterpart of the helical gear. The pitch surfaces and the nature of contact are the same as for straight bevel gear except for the difference brought about by the spiral shaped tip. So yung ang galing ng pangalan na spiral bevel gear sa shape nito na spiral shaped tip. So kumpara sa straight bevel gear natin na maingay, yung spiral bevel gear naman natin ay mas tahimik. So kadalasan do ginagamit to sa mga vehicle transmission as drive from the drive shaft. Yun lang. Next slide po. The zero bevel gears. The zero bevel gear is patented gear having curved teeth with zero spiral angle. The axial thrust loads permissible for zero bevel gears are not as large as those for the spiral bevel gears, and so through are often used instead of straight bevel gears. The zero bevel gear is generated by the same tool used for a regular spiral bevel gear. So, halos similar sila nung straight bevel gear. Ang pinagkaiba lang daw nila ay ang mas makapal yung tip ng zero bevel gears natin. So, parang mas matibay siya gamitin. Next slide po. Hypoid gears are gears frequently desirable, as in the case of automotive differential equations, to have gearing like bevel gears but with the shaft offset. These gears are called hypoid gears because their pitch surfaces are hyperboloids of revolution. The tooth action between such gears is a combination of rolling and sliding along a straight line and has much in common with that of a worm gear. Next slide na po. Spheroid gears are similar to hypoid gears but will relatively differ from their shaft offsets. Hypoid gears are relatively small shaft offset for the larger offsets. The pinion begins to resemble a tapered worm and the set is then called a spheroid geary. So mas ano yung kanyang shaft offset, mas malaki kumpara sa ating hypoid gear. Next slide na po. Gear classification according to pitch angle. So meter gears, shafts at 90 degree and 45 degrees each. Crown gear, 90 degree pitch angle. Internal bevel, pitch angle greater than 90 degree. External bevel, pitch angle less than 90 degree. Next na po. Formulas in bevel gears. Cutting or root angle. So, where yung omega natin ay equal sa ating cutting angle, yung ating gamma is equal sa pitch angle, sabay naman yung ating delta ay equal sa dedendum angle. So, yung cutting angle ay equal sa ating pitch angle minus the dedendum angle. Sa phase angle natin, beta is equal to phase angle gamma is equal to pitch angle at yung A natin is equal to addendum angle. So, para daw makuha yung phase angle, add lang natin yung pitch angle at addendum angle. Pitch angle. For pinions natin, YP or pitch angle of the pinion is equal to tan negative 1 times radius of the pinion all over the radius of the gear, equal to tan negative 1 number of teeth in pinion all over the number of teeth of gears. Sa gears naman natin, tan negative 1 radius of gear all over radius of gear equal to tan negative 1 number of teeth in gear all over the number of teeth in gear. Next na po. Face width, L is equal sa ating length of the cone, sabay yung B is the face width. So B less than or equal sa ating length all over the constant 3. Next na po. Length of cone, L is equal to length of the cone, sabay RP is the radius of the pinion and RG is the radius of the gear. L is equal to quantity radius of the pinion square plus radius of the gear square 1.5. Sa working depth, WR is equal to working depth and PD ay equal sa ating diametral pitch. So para makuha yung ating working depth, constant 2 all over sa ating diametral pitch. Total depth, WT is yung total depth natin, sabay yung ating PD is the diametral pitch. So 2.188 all over the diametral pitch para makuha yung ating total depth. Design calculations sa ating bevel gears. So strength of straight bevel gears, Fs is equals to beam fatigue strength, S is to endurance stress, B is to face width, Y is to Lewis form factor, L is the length of the cone. Beam of fatigue strength is equal to sa ating endurance stress multiply sa Lewis form factor multiply sa face width all over sa ating diametral pitch quantity length of the cone minus face width all over length of the cone. Sa atin naman dynamic load, FD is our dynamic load, FT is our transmitted load, and VM is the pitch line velocity. So para makuha yung ating FD or dynamic load, quantity 600 plus constant 600 plus ating pitch line velocity all over sa constant 800 natin times sa ating transmitted load.
So, kinig na kaya ako? Hello? So, for the sample problems, number 1, what is the lead angle of a double-threaded square thread with an outside diameter of 3 inch and TP and threads per inch of 9 halves? A, 2.79 degree, B, 4.87 degree, C, 5.87 degree, and D, 6.79 degree. So, linawin ko lang, kinig kaya.
Oo, pre.
Sige. So, ang given natin ay outside diameter or DO is equals to 3. At ang thread per inch or TPI ay 9/2. At ang kailangan natin hanapin ay ang lead angle. So, ang formula natin para mahanap ang lead angle ay lead angle is equals to inverse tan multiplied by length over pi times mean diameter. So, since wala pa tayong length and mean diameter, hahanapin muna natin yung dalawang given. So, to solve for the length, we need to multiply 2 and pitch. To solve for pitch, ang formula ay threads per inch is equals to 1 over pitch. Or pitch is equal to 1 over threads per inch. So, pitch is equals to 1 over 9/2 is equals to 2 over 9. Tapos, since may pitch na tayo, kaya Kaya mahanap na natin ang length. So let's multiply 2 and 2 over 9. So length nga is equal to 2 times pitch. So length is equal to 2 multiplied by 2 over 9. And length is equals to 4 over 9 inch. Tapos, sa mean diameter naman, ang formula ay mean diameter is equals to outside diameter minus depth of drop. At para mahanap yung height of cellar square, ang formula ay multiply 7 over 6 to pitch. Kaya ang magiging solution ay mean diameter is equals to 3 minus 7 over 16 multiplied by 2 over 9 is equals to mean diameter is equals to 2.9028 inch. So, meron na tayong mean diameter at length. Pwede na natin mahanap yung lead angle formula. So, isa-substitute lang natin. So, lead angle formula is equals to inverse tan multiplied by 4 over 9 over pi multiplied by 2.9028. At ang lead angle natin ay 2.79 degree, which is yung letter A. So next slide please. Yan. So para sa number 2 naman, 2 helical gears transmit 500 horsepower at 3,600 RPM. What should be the bore diameter of each gear? B if the allowable stress in gear shafts is 12,500 psi. So A equals to A 1.252 inch, B 1.2568 inch, C 1.3275 inch, and D 1.5276 inch. Dito hinahanap natin ay ang bore diameter. Para mahanap natin ang bore diameter, ang formula ay shear stress multiplied by allowable stress, or 16 times torque over all over pi diameter squared equals to allowable stress. Ang given natin sa problem ay power, or P, is equals to 500 horsepower at 3,600 RPM. Or yun yung magiging N natin. Tapos allowable stress, 12,500 PSI. So una, hahanapin muna natin ang torque. Ang formula sa torque ay power is equals to torque multiplied by N over 63025. Or torque equals to power multiplied by 63025. So, nangyayari ay 500 is equals to torque multiplied by 3,600 over 63025. Ngayon, ang torque natin ay equal sa 8,753.43 pound-inch. So, ngayon may torque na tayo. Hanapin naman natin ay ang shaft diameter. Katulad ng sabi ko kanina, ang formula ay shear stress multiplied by allowable stress, or 16 multiplied by torque all over pi diameter squared equals to allowable stress. Kaya ang magiging computation natin ay 16 multiplied by torque all over pi diameter cube is equals to 5,500 psi. So substitute 16 multiplied by 8753.47 over pi diameter cube or bore diameter is equals to 12,500 psi na kalalabasan ng ating sagot ay 1.5278 inch na ang sagot ay letter D. Yun.
Next problem is, two shafts are connected by spar gears. The pitch radius of the gears A and B are 207 mm and 842 respectively. If the shaft makes 350 revolution per minute and is subjected to twisting moment of 236 Newton meter, what is the tooth pressure of the two gears? The choices are 1,177 Newton, 890 Newton, 1,255 Newton, and 878 Newton. So first, our formula is tangential force is equals to So first formula is twisting moment is equal to tangential force multiplied by the radius A. So ang ating twisting moment is 236 Newton meter. So ba't siya naging 236,000? So dahil nagkaroon tayo ng conversion dahil ang ating radius ay naka-millimeter. So, i-convert natin yung Newton meter into Newton millimeter. Kaya, naging 236,000. So, by equating the given, ang magiging tangential force natin is 11,410.10 Newton. And next is for the resultant force. Our formula is cosine theta equals tangential force divided by the resultant force, where ang ating theta or ang ating angle is 14.5 degree. And by equating the value of our problem is cosine multiplied by cosine 14.5 degree equals our tangential force, which is 1,140.10 divided by the resultant force. So, ang ating resultant force is 1,177.61. So, yung answer pala kanina na dito sa tangential force is 1,410 lang, hindi pala 11,000. So, yun. And our resultant force is 1,177.61 Newton. Which ang required natin is yung tooth pressure of the two gears or yung the resultant force. And the answer is letter A, 1,177.61 Newton. Next problem is, the root diameter of a double square thread is 0.55 inches. The screw has a pitch of 0.20 inches. Compute the outside diameter. Our choices are 0.57 inches, 0.75 inches, 0.50 inches, and 0.85 inches. So So, ang given natin is, yung root diameter natin is 0.55 inches at ang pitch natin is 0.20 inches. So, ang formula na gagamitin natin is outside diameter equals to root diameter plus 2 and 1/2 multiplied by pitch. So, equating the given, our outside diameter is equal to 0.55 inches plus 2 and 1/2 multiplied by our pitch, which is 0.20 inches. Our outside diameter is 0.75 inches. So, siya is letter B. And for the last problem, a set screw is necessary to fasten a pulley to a 2 inches shaft while transmits 3 horsepower and rotates at 150 RPM. Find the torque on the set screw. Our choices are 105 feet-pounds, 1,260.5 feet-pounds, 1,245 feet-pounds, and 3,421 feet-pounds. So, ang ating formula na gagamitin is power equals to T multiplied by the speed divided by 63,025. So, ang given natin ay is yung power natin na 3 horsepower and yung ating speed na 150 RPM. So, ang ating required is yung torque. At by equating the given values, 3 equals to torque multiplied by the speed, which is 150 RPM, divided by the constant 63,025. And our torque is 1,260.5 inches feet 1,260.5 inches pounds, and by converting it to feet, our value will be now 105.04 feet pounds, and the answer is letter A. And that's all for our report.
Hello, hello. Okay na? Ayan. So, group 4 po, screws and gears. Thank you po for listening.